Trig function evaluation. One of the problems with most trig classes is that they tend to concentrate on the right triangle trig and do everything in terms of degrees. Then you get to a calculus course where almost everything is done in radians, and the unit circle is a very useful tool. So first off, let's look at the following table to relate degrees and radians. So the first row is degree, the second row is radians. 0 degrees is 0 radians. 30 degrees is pi over 6 radians. 45 degrees is pi over 4 radians. 60 is pi over 3. 90 is pi over 2. 180 degrees is pi. 270 is 3 pi over 2. And 360 is 2 pi. Now make sure to know this table. There are, of course, many other angles in radians that we'll see during this class, but most will relate back to these few angles. So if you can deal with these angles, you will be able to deal with most of the others. Now be forewarned, everything in most calculus classes will be done in radians. Now let's look at the unit circle. Below is the unit circle with just the first quadrant filled in. The way the unit circle works is to draw a line from the center of the circle outwards corresponding to a given angle. Then look at the coordinates of the point where the line and the circle intersect. The first coordinate is the cosine of that angle, and the second coordinate is the sine of that angle. So I repeat, the first coordinate is the cosine of that angle, meaning that the first coordinate of the ordered pair is the cosine of that angle. And the second coordinate is the sine of that angle. So therefore, the second coordinate represents the sine of that angle. Now there are a couple of basic angles that are commonly used. These are 0, pi over 6, pi over 4, pi over 3, pi over 2, pi, and 3 pi over 2 and 2 pi, and are shown below along with the coordinates of the intersections. So from the unit circle below, we can see that the cosine of pi over 6, so the cosine of pi over 6 is going to be 3 pi over 2 because that is the x-coordinate. And the sine of pi over 6 is going to be 1/2 because that is the y-coordinate of the unit circle. Now remember how the sines of angles work. If you rotate in a counterclockwise direction, the angle is positive, and if you rotate in a clockwise direction, the angle is negative. Recall as well that one complete revolution is 2 pi. So the positive x-axis can correspond to either an angle of 0 or 2 pi, or 4 pi or 6 pi, or negative 2 pi or negative 4 pi, etc., depending upon the direction of rotation. Likewise, the angle pi over 6, to pick an angle completely at random, can also be any of the following angles. So pi over 6 plus 2 pi is equal to 13 pi over 6. So you'd start at pi over 6 and then rotate once around counterclockwise. Pi over 6 plus 4 pi is equal to 25 pi over 6. You're going to start at pi over 6 and then rotate around twice counterclockwise. Pi over 6 minus 2 pi is equal to 11 pi over 6. So that means you're starting at pi over 6 and then rotate once around clockwise. And then pi over 6 minus 4 pi is equal to negative 23 pi over 6. So you'd start at pi over 6 and then rotate around twice clockwise, and etc. So in fact, pi over 6 can be any of the following angles. Pi over 6 plus 2 pi n, where n can equal 0, plus or minus 1, plus or minus 2, plus or minus 3, and so on. In this case, n is the number of complete revolutions you make around the unit circle, starting at pi over 6. Positive values of n correspond to counterclockwise rotations, and negative values of n correspond to clockwise rotations. So why did I only put in the first quadrant? The answer is simple. If you know the first quadrant, then you can get all of the other quadrants from the first, and you'll see this in the following examples.